Hey y'all. Today we're going to be talking about chapter 3, which is numerically summarizing data. Now, in particular, we're going to be talking about section 3.1, which is measures of central tendency. So, what we want to be able to do is to take in any type of data that you can imagine, and we want to give you guys numbers and or statistics that can basically summarize the data. Imagine your boss coming up to you and saying, "Hey, give me two numbers, let's say, that tell me the most about the data that you can imagine." Well, that's what we're diving into. The first type of number that we'll talk about is a measure of central tendency. Now, right away, what you can imagine this being is a measure of, hey, where is most of the data located? Where is the center of the data? Let's dive in. Well, let's talk about being perfectly average. We're often interested in what the average individual is like. I mean, you could be talking average height, talking average weight, what have you. Now, by the word average, what we're going to call in statistics, that word, is the mean. So mean means average. Now, since we've talked about a distinction between a population and a sample, a population ideally what we're going after, but a sample the more achievable mean to get towards the population, we have different words different letters representing the mean of each thing, the population of the sample. For instance, mu, which is pronounced mu, will denote the population mean. So if you ever see something like mu equals 19, that means the population mean is 19. Now, if I ever want to talk about the sample, I'll talk about x bar. That is x with a bar over top. We're not really reinventing the wheel here. So if I say something like x bar equals 18, that means my sample mean is 18. So my sample average is 18 in this circumstance. Now, many of you guys actually know how to find averages already. All you have to do is add up all the observations and divide by the total number of observations. So, for instance, if I have someone that is, say, 70 inches tall, 72 inches tall, and 74 inches tall, so 5'10", 6 foot, and 6'2", respectively. All you need to do to figure out the average of these three observations is to add them up and divide by the total number of observations, which in this case is 3. Now, if you were to do this math, you would get that the answer is 72. So your average for that data set is 72. Now, one thing I want to point out, notice that these formulas are actually exactly the same. The only difference is that with the population mean, we're going to be using capital N, and with the sample mean, we'll be using lowercase n. This is because we denote the overall population size by capital N, and we denote the overall sample size by lowercase n. In both cases, you're going to add up all possible observations and then divide by the total number of observations. So, great. You're doing the thing you're used to. For instance, find the sample mean if the sample is given by 18, 9, 7, 10, 16. Okay, well, we can actually do this one relatively by hand. All we would do is take 18 plus 10, so 28. Oh, excuse me. Wow. I am messing up already. 18 plus 9. I had 10 in my head. So 18 plus 9 is 27. Plus 7. So 27 plus 7 is 34. Plus 10 is 44. Plus 16 is 60. And we're dividing by the total number of observations possible, which is 1, 2, 3, 4, 5. So we got 60 over 5, which will end up being, I believe, 12 as your average. Now find the sample mean for the following. Okay, this one, the sample size is 12, so we actually already know what we're going to be dividing by in this case. We'll be dividing by 12. All that you need to do is actually add up every single thing. Notice all the plus marks I can throw in there. Well, let's pause on that for 1 second. Let's go here and let's use our friend Excel. So allow me to copy and paste this in Excel. Now, if you want to get rid of the weird formatting, go to no fill, go to text color automatic. You know, you can turn off the special formatting and maybe make it something reasonable like 12. Let's go ahead and cut paste everything down low. So cut paste, cut paste, cut paste. I know this is a very fun part of the lecture. Cut paste, and last but not least, cut paste. So get everything in one column. Whoops. Okay. Well, cut paste. Now everything's in one column. Notice I retained all 12 of my observations. What you can do if you want to compute the average is do something like this. Equals. So equals in Excel tells you that you'll be calling a command. When you're calling a command that basically says, hey, computer, get ready, I'm about to do something. So equals, well, instead of mean, unfortunately, they use the word average. So if I start typing in average, notice it pops up. If I double click on it, notice that a parenthesis opens up. Once I get this right here where a parenthesis opens up, I'm able to drag and highlight, so I am dragging the whole time, all values I care about. It pops up A1 through A12, A1 colon A12, which is the column A and the rows 1 through 12. If I then close my parenthesis, that tells me that's all the values I care about, so I only care about A1 through 12. And if I hit enter from there, notice my average is 101.833. Not too bad. In fact, to prove my point, let's go 18, 9, 7, 10, 16. So I'll do this over here. 18, 9, 7, 10, 16. Perfect. Just wanted to double check. What I could do is equals average. You don't have to do all caps. If I click on this, double click, it opens up a parenthesis. I drag and drop. I close the parenthesis once I realize that all the cells that I care about are included. And I hit enter, and bam, my average is 12. This is a very quick way of doing this. By the way, another quick way, if I just copy, paste this all right here, notice what I could do is actually just highlight it right away and go over to this button right here. And there's actually an average button, and it pastes it right below. But I want you guys to be able to know how to actually type in the average command. Let's go back to the PowerPoint. So average, add every value up, and then divide by the value you're at. Now, what's another measure of your central tendency? Well, another measure could be your median. No doubt you've heard that word before. Median is going to be the value that lies in the middle of the data when arranged in ascending order. Now, I cannot emphasize this part enough. When arranged in ascending order, you need to put that data from lowest to highest, and you're literally just going to take out the middle value there. Now, instead of having X bar for our sample mean or mu for our population mean, we'll denote the median in either case by just a capital M. So capital M, kind of nice and simple. Capital M is your median, which is the middle value. Now, how do you find the median? Well, it turns out it's actually pretty simple. First off, and the hardest part, will be that you first arrange the data in ascending order. So I might give you the data in kind of a mixed up order as I did here. Your first task is to arrange it in ascending order. 9, 7, or excuse me, wow, I said that backwards. 7, 9, let's say 10, 16, and 18. I'll keep coming back to this. So first step, done. Arrange it in ascending order. Second step, if the number of observations is odd, then the median is just the middle value. What do I mean by this? Okay, let's go back to our ascended order sample. All you should do is cancel out the lowest and the highest value in pairs. So notice I'll cancel the 7 and the 18 in the same step. Okay, what's my next lowest and my next highest? Well, my next lowest is 9. My next highest is 10. So I cancel those in the same step. Since I only had 5 observations and that is an odd number, notice I only have one number left, 10. My median, therefore, is 10 here. Cool. Love it. Median, the middle value. So we tried the odd one. Turns out if the number of observations is even, though, you have to do one more thing. So let me give you an example real quick. Let's do 1, 2, 3, 4, 5, and 6. So this is a very even sample. It's kind of a boring sample, but hey, you might run into it. So, okay, first arrange it in ascending order. Great, we got that done. Notice the number of observations is even. We have 6 different observations. Well, let's do the thing that we were just doing. Cancel, cancel, in the same step. What's my next lowest and highest? They die at the same time. Not trying to be dark. 2 and 5 die at the same time. And, oh crap, I'm at an impasse. If I were to cancel 3 and 4 at the same time, notice I'd be left with nothing. Well, your median can't be nothing. It can't be this gap, whatever the heck it is between here. So instead of claiming that there's no median, what we do is we take these two numbers that are left over and take the average of them. So since 3 and 4 are left over, all we do is do 3 plus 4 divided by 2. Same way you'd be doing it in this step right here. Add up your observations, only the middle two numbers, and divide by how many there are. 2. You end up getting 7 over 2, which is 3.5. So we would say that our median is 3.5 in this example. Which, notice, hey, that's the middle number between 3 and 4. So, hey, median's kind of nice. You just cancel out pairs until you get down to that middle number. And if you have 2 middle numbers, it's kind of a tie. Take their average. Hey, y'all both get first place. Let's try the following. Okay. Find the median salary if a sample is given below. We got 25, 35, 40, 50, 50, 50, 55, 55, 65, 75. Well, first off, let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have an even amount. Not a problem. Let's cancel out the lowest and highest in each step. Step 1, these two are gone. Step 2, these two are gone. Step 3, 40 and 55 are gone. Step 4, 50 and 55 are gone. Notice we're left with 50 and 50 as our observations. Now we need to find the winner. Well, since you're an even number, we're going to say you guys tie. So we end up taking the average of our middle two observations. Now y'all might think this is stupid because what's the average of 50 and 50? Well, you could add them up and divide by 2, the total number of observations, and you'll get that the average is 50. Therefore, our median for the above example is 50. Great. Let's do the second example. Find the median of the following sample. Notice how many observations we have. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's even, not a problem. But the more annoying thing about this one is it's not in ascending order. Well, let's get it there. I have a 1 over here, so let's go ahead and rearrange it. We got 1, and then we have a 2 right here, and then I see a 3, and then we have a 5 next up, and then we have 2 6s, and we have a 7 and an 8. Okay, cool. I put it in ascending order. Okay, what do we do from here? Well, let's go ahead and cancel out the lowest and the highest value in each step. So 1 and 8 are gone. 2 and 7 are gone in the next step. 3 and 6 are gone. And oh no, we're left with 5 and 6. If there was just one number, well, that would be the median. Not a problem. But since there are two numbers, we'll take the average of the two, 5 plus 6 over 2, to get 5.5. And therefore, our median, capital M, is 5.5. Now, just to show you that our stuff actually carries over, so pause here if you want any of the markings. Just to show you that our stuff carries over, let me go ahead and type all these in Excel to show you what you can do. So, let's take that above example, because I feel like that's a little more confusing with the crazier numbers. 25, 35, 40, 50, 50, 50, 55, 50, well, not 5. Let's go. 55, 65, 75. Okay, cool. I got everything. And in the next column, I'll even do the next one in non-ascending order. 3, 2, 6, 5, 6, 8, 7, 1. Awesome. Okay, so we have everything here. If I go down here and I say equals, because when I say equals, I'm telling the computer to do something for me, and I start typing in median, well, wow, median pops up real quick. Let me double click on median, and let me highlight the cells I care about. So drag and drop until I get all the cells. Now from here, I need to close off my parenthesis. That is an important point. Make sure you close off your parenthesis like that. So pause here to see how my command looks. And when I hit enter, notice my median for this one is 50. Awesome. Now here's where Excel is amazing. If I do the same thing with this column right here, and notice it is unorganized. I have not went over to sort and filter and sorted from largest to smallest. I could do that and do the process I cared about. But I'm going to leave it unfiltered, unsorted. If I do equals median, hey, that command pops up. I double click it and I drag and drop. And I close my parenthesis. Notice that Excel does not care if it's ordered or not. It still gives you 5.5 as an answer. And then it barks at me because I clicked too hard. So you don't even have to order it if you are, so long as you know that the command is equals median. And then you just drag and drop the values you care about. Median is an amazing function. Just like mean was over here. So we did mean over here. And sorry, that was an error. I accidentally clicked something. So let's go back to the PowerPoint. Now you might want to compare the mean and the median in this case. Well, which one do you use? Okay. We have two measures of central tendency, meaning where the data is centered. Which one's better, the mean, the average, or the median, where your kind of middle number is? Well, let me go ahead and provide an example. Turns out the mean, although you kind of like the average, we're going to say that the mean is not resistant. And let me highlight that fact, not resistant. Now, what do I mean by resistant? Well, in this case, I mean that the mean is severely affected by extreme values. Whereas the median, it turns out, is typically not affected by extreme values. Let me go back to my Excel sheet real quick and type in the following samples without 200. So let's go ahead and figure out 3, 2, 6, 5, 6, 8, 7, 1. Let me go ahead and copy this 4 different times. Y'all ready? Okay. Well, I need to copy. Well, let's have some gaps in between. Paste, paste, paste. Okay, now it's okay. There we go. Finally. Now let me add on to each other one, so the second and the fourth one, the number 200. Now what I want to do in this case is to calculate the means and the medians of each respective column. So let me go back. Let's first off calculate the mean of this column without 200. That is a big emphasis. So equals average. Hey, there's a command that does average. Remember to put that equal sign up front. So equals average. I drag and drop after double clicking, and I close my parenthesis off. If you have a parenthesis here, you need one here. I hit enter. Boom. My average for this column is 4.75. Let's do the same thing here. Equals average. So you need that equals, open parenthesis, and highlight the cells you care about. Now we're including 200. Close parenthesis. Wow. That average shot from 4.75 up to 26.44444. Kind of a big deal. Well, let's try medians instead. Equals median. Okay, there's a command. I double click on it. I drag and drop on the cells I care about. And I close my parentheses. So equals median. And then drag and drop. I hit enter. My median is 5.5. This is different than my average. So it's important to note that mean and median might not line up. But that's not a problem. But let's see what happens to the median over here when I include 200. Equals median. Double click, drag and drop, close parentheses. Wow. Even when I included 200, my median stayed at 6. It turns out your median will be very resistant to you having an extreme value in your sample. Your average, on the other hand, will bump from 4.75 to 26. It's not too resistant. The best way I could describe this is imagine if you were in a class where everybody bombed an exam except for one individual. That one individual getting 100 on the exam will ultimately bust the curve for the class, and that's usually not a good thing if you're in the underperforming group. However, your median will not be busted from that one individual. The last measure of central tendency will be the mode. So what is the mode? Well, the mode will be the most frequent observation. If I see one score pop up the most amount of times, hey, that's your mode. Now, there are 2 caveats to this. If no observation occurs more than once, then hey, the data has no mode. So it just turns out that, yeah, if you don't pop up more than once, like great. We're going to say you have no mode. Everything is perfectly uniform. Now, here's the crazy part. If there is a tie, we'll say that there are 2 modes or 3 modes, depending on how many things were tied. Now, the nice thing about the mode is the highest peak on the graph of a distribution. That is the nice thing about the mode. It is the thing that appears most often. By the way, it might not be exactly where the center is, but it's the thing that appears most often. So there's no need for the mode to line up with the median, and there's no need for the median to line up with the mean. These are all very different measures of centrality in your data. They could all line up, turns out, but they don't have to. There's no obligation for them to all agree. As an example, hey, here's a nice unimodal distribution, uni meaning one, where, hey, that's the data set right here, whatever this number is that goes here, that's the one that pops up the most often. Here's a bimodal distribution, meaning, hey, two different things pop up the most often. And it turns out this one is trimodal. 1, 2, 3 things pop up the most often, and it is important that they're all the same height, just like these two. But notice that you could have multimodal, meaning you could have 4, 5, 6. You can have infinite amount of things that pop up the most often. So the mode tells you where data is centered, but there's no need to just have one mode, which is kind of a goofy thing about the mode. Now that's it for measures of centrality. What I want you to focus on are mean, median, and mode. On your first exam, you will be asked to both figure out, not both. You will be asked to figure out all three of these measures of centrality. I'll give you a big set of data and I'll say, hey, find all three. Notice that with mean, you have to add up all the values and divide by the total number of values present. With mean, you first off arrange in order of ascension and then you cancel until you get to the middle value. And with mode, you literally just pick the value that appears the most often. So if I may go back to, say, this one right here, you notice the 6 appears twice and no other number appears more than once. So your mode would be 6 in this case. Your mode here, 50, 50, 50. Your mode is 50, which lines up kind of closely typically with your median and mean. There's no obligation for the three to actually agree though. That's all I have for this section. Please contact me if you have any questions or comments on the material. Best of luck on the homework, and we'll see you next time. Bye.